Good morning, Prob-Stats students. This is Mr. Mitchell. We're going to be looking at central tendency this morning. We're going to go through how to calculate a lot of this stuff by hand, and then we'll also take a look at the calculator and see how it can help us. When I say calculator, I'm talking about one of the nice TI-84s or 83s or something like that. So if you have those, if you've downloaded it on your laptop, it should make things a lot easier for you. So we're going to start talking about some things. The mode is the value that occurs most frequently. Who needs to know the mode? Typically, a lot of businesses need to know the mode. They want to know what product is sold most, what engine breaks down the most. Businesses need to know the frequency of how much certain things occur the most, and that's the mode. We don't do a lot with the mode, but the mode is very practical and very necessary. The median is the middle number. You've probably heard about a median in terms of the highway on an interstate. The median is in between the two roads, whether you're going northbound, southbound, or eastbound, westbound. The median is in between. So that's the central number. The mean is when you add them all up, add all the numbers up, and divide by how many there are. It's also known as the average. That's how you calculate it by hand. So find the mode. There's your data set. Which one occurred the most? Finding the median, we do need to put it in order from smallest to largest, and then we pick the middle number. Or if there's two numbers in the middle, you would take the average of those two numbers. So if you had a list of 5 numbers, the third number is the median. If you have a list of 6 numbers, the third and the fourth number, you would have to find the mean of those two numbers. So that's how you calculate the median by hand. So find the median. Well, here's your data, and you put it in order. So what's our median here? 1, 2, 3, 4, 5, 6, 7 numbers. The median here is the middle number, it's 3. Down here, 1, 2, 3, 4, 5, 6. There's 6 numbers. Put them in order. There isn't a middle number. So what's halfway between 31 and 43? You need to add those up and divide by 2, and it becomes 37. So that's the median of this data set. So you can see an odd set and an even set, what you have to do to find each. So finding the mean, we are going to talk about sigma notation a lot this year. So we need to know what this symbol means. Again, in math, we don't like to write words. So we can write the word sum the following out over and over again, or we can use the symbol sigma. It's called the Greek letter sigma, and it stands for sum the following. So what we need to do is we need to add all these up and divide by how many there are. That's how you find the mean. Okay. So if you add up 6, 7, 2, 3, 4, 5, 2, and 8, you get 37, and then you divide by 8. So the average is 4.625. That would be your mean here for that data set. Again, notation-wise, we need to get used to knowing what notation means. It's just like if I send you an emoji, you need to know what an emoji is, or what does LOL mean. There's a lot of abbreviations that people use, acronyms. It's the same thing in math. What does lowercase n? That represents a sample. That's the sample size. Capital N represents the population size. So you just need to be aware of that. For finding a sample mean, this is the notation we use. We use X with a little bar over it. And then this is the way it's written. When you're just finding the mean, a lot of times you don't have to write all this out. You just find the mean. Population mean, we use this little U. It's a U, it sticks down below a little bit. We call it mu, but it's a U. And you can see it's the same formula except for different letters because it's representing something different. It's just like your initials. Your initials represent you. Sometimes we use your initials, sometimes we use your full name. Resistant measure. So an example of resistant measure is if we look at the ages in our class. Who do you think is an outlier for the ages in our classroom? I know we're not in class right now, but who is an outlier? Well, I would be an outlier. I am older than you by several years. I am different than the rest of you. I am an outlier. So the mean is less resistant. If we take the average, if we take the mean age of our class, including me, the mean is going to be higher. It is less resistant. The median would be a very accurate measure of the middle of our age of our classroom. Because my age really doesn't have that much influence over the median. Because whoever the youngest person is in the class, even if they're 16 years old, that cancels out my age so that we will get an accurate representation of what the middle age of our classroom is. The mean would be higher because of me. So one way we avoid having the mean being non-resistant is we trim it. So we figure out how much we want to trim it by, and then we cut off so many numbers above and so many numbers below. And we'll practice that here in a minute. So to calculate a 5, it's usually 5 or 10%, could be 20%, but it's not usually that high. It's usually 5 or 10%. You have to arrange them in order from smallest to largest, and then you're going to delete the bottom 5 or 10% of the data. And then you're going to delete the same percent off the top. So you have to figure out what 5 or 10% is of the data first. You can't just take 5 numbers or 10 numbers off. You have to calculate what 5 or 10% is. So compute the mean of the remaining 80 or 90% of the data. So it's a percentage, not 80 or 90 data points. It's not, we don't know if there's 100 data points. There might only be 20. And then if we're doing a 10%, what's 10% of 20? Take 0.1 times 20, that's 2. So if it's 10% of 20 data points, you'd cut off 2 on both sides. So here's the example. So we put our numbers in order. We could find the mean of this, but we want to do a 10% trim mean. Why? Because look at this number. This 60 is clearly different than everything else. See, this 15 and 17 aren't that far apart. 15 to 36 isn't that far apart. But the 60 is much different. It's probably going to be an outlier. So we will trim the mean to try to avoid 60 over-representing this group. So what's 10%? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So what's 10% of 10? 1. So you're going to delete the top 10% and the bottom 10%, which is just one number. So the new data set, you're going to cut off 60, you're going to cut off 15, and then everything else stays the same. You still have 17 to 36. So now your new data set, it's a 10% trimmed mean. You're going to add all these up. You're going to divide by 8, and then your new mean is 24.8. The untrimmed mean is going to be much higher than 24.8 because the 60 will make it larger. The 15, yeah, it makes it smaller, but 15 is really close to 17. It doesn't have as much weight as the 60. All right, so that's the end of the slideshow, but now we're going to take a look at the calculator. So we need to have our calculator ready here. And just bear with me a second as I kind of get the screen here for you. You need to go to Stat, and then you need to go to Edit, and then you need to type in some numbers. So for my numbers, I have 30 numbers in here, and these are the ages of students in something. It doesn't matter, it's just made up numbers. So we go from 1, 2, 3, 4, 5, 6, 7, all the way down to a 19. Now notice there are 30 data points. If you're not sure how many numbers you have, if you look down here, if your cursor's on it, it'll tell you have 30 numbers. We are in list 2. Okay, list 1 I use for another class. So I'm not going to delete that. I need that for another class. You can store up to 6 lists. See, I have other data in here in list 6. So I just need to know which list I put my stuff in. You can actually make more, but you have to name them a special name. So these lists can be found if you look at the numbers 1, 2, 3, 4, 5, and 6. They're L1, L2, L3, L4, L5, L6. You just need to hit the blue button. So you have to enter your data. So we do that first. Enter all the data. Boom. Got that all in. Then I'm going to go to second quit. I close out, and then I go back into stat. Don't go into edit. Go to calc. Now right now we only have one list of data. So we are doing this for a 1 var stats. One variable statistics is what it's abbreviating for. So I'm going to hit enter on that. So now I need to know where I typed my data in. If it's in L1, then it's fine. Usually L1's the default. It comes up automatically. But I type mine into L2, so I'm going to hit second L2. Frequency list, you don't need to pay any attention to. That's something else you don't really need to know about. And then we're just going to calculate it. So there's my mean. So it did a lot of work for us, but you got to know what you're looking at. Okay? And a lot of this stuff is very important. Some of it we use right now. Some of it we will use later in this unit or in other future units. But right here's our mean. It's a 9.46 repeating. Okay. This is just the sum of x. We'll need that later. The sum of x squared we'll need later. These are the 2 standard deviations. If you're dealing with a population, you look at this one, the sigma. If you're dealing with a sample, you use this one. You do need to know whether you're dealing with a sample or a population. Yeah, this is your sample size, and then this other information is very important to us. This is how you make your box and whisker plot. Here's your min, and your max. Here's your quartiles, and then there's your median. Okay? So knowing this information is great. But what if I'm asked to find a trimmed mean? Well, what percent are we going to trim the mean by? So let's just keep it consistent. Let's just do 10%. That's what the example in the book was, or on the notes were. So how many data points did I have? So I'm going to go back in. Remember I said I had 30 data points. If we go through, count up, you can count them or just look at the last data point. Notice 19 is the last number. There are 30 numbers in my data set. So what I do, I take 30 times my percent. So 10%, you can't take it times 10. That's 300. 10% is 0.1. So I need to cut off 3 numbers. And that's 3 numbers on the top and 3 numbers on the bottom. So what I like to do, because sometimes you may want to put the numbers back in. So look at the bottom list. I'm going to cut off 1, and then I'm going to delete it. And then I'm going to cut off a 2, and then I'm going to delete it. And then I'm going to cut off another 2. And then I'm going to delete it. You might say, well, Mr. Mitchell, there's another 2. Yeah, that's okay. It was the 4th number, so it still stays in the data set. So 1, 2, and 2 got cut off. So now I need to go to the higher numbers, and I need to cut off 3 numbers there. You have to trim both ends. You can't just trim one end. So now I'm going to cut off 19, 18, and 18. So I come over here, I need to cut off the 18, and then the 19. So I like to record what numbers I did trim off so that I don't forget which numbers, in case I need to add them back in. So to delete numbers, you just use the delete button, either on your computer. So now, if you've started with 30 and you trim off 3 on each side, and you're trimming off 6, I should have 24 numbers, and I do. And then all you do is stat, calc, 1 var stat. It's still list 2. Calculate it. And then you can see there's your new mean. So you trim the mean, and now it's 9.33. And I like to compare the median and the mean. So the median is 8.5. The mean is 9.3 repeating. So that is how you trim a mean. You can do it by hand, or you can use a calculator. If you have questions, let me know.